So now, hello everyone. Welcome to lecture. I would say still introduction is going to be lecture 0. I'm going to complete this lecture for you today. The good thing is we've practiced a lot of information about the microcontroller, which is the best microcontroller for automotive application during the lab time. Now, I'm pretty sure everybody has a good enough information to understand what I'm going to talk about. Today, I'm going to cover the numbering process. Remember, during the lab time, I told you we are going to practice how to convert binary to hex, hex to decimal, and so on. That's the time. Grab your maybe, if you are very used to writing down, taking a note. Also, you do not need to, because any problem I'm solving in here for you, first thing first, you can find the recording, everything on the screen will be recorded, and I'll post it on Avenue. Of course, except that, in addition to that, you can see the solution to all the problems that I'm going to solve for you in addition to whatever recording. It's going to be available to you on their lecture slide. For example, today I'm talking about this module. This is the solution to the problem. I already typed them to make sure everybody can see them, read them clearly. So solutions are already there, and I'm going to also do it during the class. Before I start, if you have any question from the Monday lecture, from the lab, please bring it to my attention. First, I get those questions, and then I try my best to add a little bit more information. How about that? Anything for me? No? So, if that's the case, let me one more time summarize. We are here. First half of the semester, I'm going to focus on embedded system. I already said what embedded system is. One more time, very simple. Embedded system means any control system which has both hardware and software, and they are trying to communicate, exchange some information, and usually information are coming from the software being uploaded to the microcontroller, which is the hardware. And through that, a set of input output, which usually for automotive, it could be any of the sensors, proximity sensors, maybe temperature sensor, light sensor, any, we are talking about automotive, any available sensor inside the automotive could be the output for all of those programming inside the software. Here for this course, you notice that we are using Code Warrior, and of course the language is going to be C. I explained why is that, simply because C is more capable of interacting with hardware than C++. C++ has a lot of limitation. It's not strong enough to communicate with hardware. That's the reason behind it. I already show you how it looks like, but in the lab, in actual microcontroller, and this is the picture for the same microcontroller, we are looking at HCS12 family. And now this is the HCS12 family, and we are going to now learn about computing system. Before everything, for computing system, we need to understand some basic information. First part of information is going to be about the software. Software means whatever inside the computer. Computer has RAM, input and output, which has been introduced to you maybe from day one being in engineering school. So you are familiar with that. I taught you maybe a first year, or somebody else taught you in the first year. Now we are focusing more on numbering, because computer cannot understand everything the way we do. So human language is more close to decimal. Decimal means numbers starting from 0. Any number starting from 0 to 9 is called decimal. Decimal is understandable for human, but how about for machine? Machine cannot understand this. So this is the human language. But we need another sort of language which is more easy for machine, or I would say computer, to understand it, which is a combination of only 0 and 1. We call it also on and off, right? On, off, 0, 1 is the same. So 0 to 1 and 0, I would say, and 1 is called binary, and binary is only computer language. So 1 and 0 or binary is not understandable for us. Decimal, which is 0 to 9, is not understandable for computer. You have to find a way, which is a good method of communication between us and computer. There is another way or another numbering which we call it hex, actually standing for hexadecimal. Decimal in here, decimal is a base 10 numbering method. If I write with red, is it comfortable for you to see? If not, I can change the color. It's good? You can see? Just in case that might hurt some students, I'm gonna switch to a different color. Binary is base 2, right? So base 2 is good for computer. Base 10 is good for us as human. We have to find something in between, which is hex. Hex is base 16. In here, we have only 16 symbols, which is a combination of numbers and letters. Simply means in hexadecimal, we are going to use numbers 0 to 9 and then some alphabet. What are those? A, B, C, D, E, and F. All together, we are going to have only 16 symbols right in here, which we are calling them hexadecimal. I'm already having a table in here. You do not have to memorize it. If you do, that's perfect, that's helpful. It will speed up the process of conversion for you during the class time, later at work, more specifically during the exam time. Still, I provide the table, but you may want to learn it in case you wanted to speed up the process. So this table is something that we have to use it as reference in order to convert binary to decimal and decimal to hex. Remember I said, if I'm looking at hex, hex is gonna be 16. So for every single number or every single letter in here, I have something in binary which is equivalent. During the lab time, when I want you to turn on or turn off some of those little switches, remember the blue or red, or the LEDs right on top of those switches, it simply means some of them supposed to go on or off like this. And each of this means something, which we are going to practice them today. So now let's practice how we can convert some binary to decimal or decimal to binary. And then later, since there is no way to have a direct conversion from binary to hex, we have to go through 3 processes. This part is really important to learn, kids. Try to learn it while I'm teaching it because it's a part of even your test 1. It's easy to understand, super easy to understand, but sometimes you may think since it is easy, it's not important. It is important. So try to learn it. So let's start with some conversion in here. Suppose I'm having a binary number or a decimal number. I'm going to start with decimal, base 10. I have 25. If I have 10 in here, now I want you to say which kind of number is this number. 25 base 10 means which category? This is decimal. Why? Because it's base 10. I mentioned decimal. This is base 10. So now I'm going to convert this guy to a binary number. Pay attention. How do I do it? It simply means I'm converting base 10 to base 2. 10 to 2. I have to divide it by 2. And each time I have to take the remainder in order to convert it to only 1 and 0, because remainder couldn't be anything but 0 and 1, right? So let's do it together. So I take 25. I divide it by 2. So then this is going to be my first remainder. Now again, by 2. This is going to be my next one. Then again by 2. This is my next one. Again by 2. And I'm done. Right? So what do I call this stuff right now? I call this one most significant bit. And I call this one least significant bit. So in order to convert 10 to 2, I start from most significant bit to least significant bit, right? So I'm gonna put it down like this: 1, 1, 0, 0, 1. What is the base? What's the base now? 2. So now I have it converted from decimal to binary. Everyone got the point? And always I go from most significant to least significant, not the other way around. Any question? It was easy to understand, right? You got it? Good. So now, what if I'm gonna do exactly opposite? What if I have been given a binary number and I'm supposed to convert it to decimal? To make it a little more understandable for you, I'm gonna use exact same numbers. Also, I have other numbers for you to practice, but I'm gonna do it exactly the same. Now, suppose I have this way. I have the binary, and that binary is 1 1 0 0 1 2. I know this is binary because it's base 2, and of course because it's a combination of 1 and 0. I'm asked to convert it to decimal. How do I do that? Who can tell me? How do I convert that? Any idea? To convert binary to decimal, I'm having some equation. That equation is general, regardless of what kind of number I'm gonna use in here. So I would say the decimal number, as you can see in here, is equal to the sum of binary digits. Sum of binary digits, suppose I'm having something like that. Dn minus 1. And these are all going to be my binary digit, D3, D2, D1, D0, and so on, right? So now I'm going to convert it. My decimal equivalent is going to be from here, D0 times, it's going to be times their power of 2. Means like in here, 2 to the power of 0 plus D1 times 2 to the power of 1 plus, I just continue like D2 to the power 2 to the power of 2 and so on. Keep this in your mind. This is the general equation regardless of which kind of conversion we are going to practice. Okay? Now I have an example which we are going to convert it together. So example is 1 1 0 0 1. We have to do exactly the same. So means each time take 1 and then continue until you can calculate it. So you have to say, for example, 1 times 2 to the power of 0. How many numbers do I have in here? 1, 2, 3, 4, 5 numbers, right? I have 5 numbers. So I start from 0 and I stop at 4. And I continue like this, and then I add them up. So I have 1 times to the power of 0, and then I have 1 times to the power of 1, then plus 0 times to the power of 3 plus 0 times to the power of, and so on. I continue, and then if I add them up, result is going to be 25. And 25 is the decimal equivalent. Make sense? Another example to make sure everybody got the point. Another example is, let's say I'm having 1 1 1 0 0 1 2. Means again I'm having another binary. So I'm going to convert it to decimal. This time, how many number do I have? 6. I have 6 number, but remember, binary is by 1 up. Therefore, I have to start from 0 and I have to stop at 5, right? So let's do it. I'm going to say now, I have 1 times 2 to the power of maximum is 5 because I have 6, maximum becomes 5, plus 1 times 2 to the power of 4 plus 1 times 2 to the power of 3. And then I've got 1 0 in here times 2 2. And then another 0 times 2 1. Bit more space in here. And then the last one is going to be 1 times 2 to the power of 0. And what's the result then? I have to add them up. If you do so, it's going to be 57 base 10. You can use your calculator. It's easy right now to understand. Make sense? Everyone got the point? So in here, I had only 1, 2, 3, 4, 5. I have 5 numbers. So I start from 0 and I finish at 4. So for example, in here, I can say, I'm going to complete this one also. 1 times 2 to the power of 4 plus 1 times 2 to the power of 3 plus 0 times 2 to the power of 2. And of course, another 0. And I finish it up at 1 times 2 to the power of 0. Then I'm having the same thing, 25 base 10. Make sense? Everyone got the point? So far we learned how to convert binary to decimal and how to convert decimal to binary, right? Next, we already practiced those. Let's look at hex. Remember, for hex, we have some table. Best is to always have the table in front of you. Like I'm gonna take this table, bring it with me to make sure you know. I know it, but if it is new for some kids, so I'm gonna bring it to the solution page and I'm gonna calculate for you some hex equivalent. Okay, so suppose I'm having again some binary number. It's a big one. It's 1 0 0 1 1 1 1 1 0 1 0 1. There is a rule of thumb in here. Anytime that I'm having a huge binary number, a combination of zeros and 1, I always start putting them in a group of 4. This part is the tricky part. From right to left, not otherwise. Right to left means I start putting them in a group of 4 like this. This is first group. Then this is the second group. Then this is the third group in this example. You may ask me, what if for the last group I'm having less than 4 number? What would I do then? Like for example, if in here I had only 0 and 1, what should I do? Then, yes, add 2 zeros. That's why we start from right to left. If I'm having only 2, 3, or even 1, then I start adding zeros to make sure it becomes 4. Why? It won't impact the final result because zeros on the left side at the end of the day will be resulted in 0. Therefore, it doesn't matter. Either you can add more zeros to still have a group of 4, or you leave it as it is. Anyway, that's gonna, after calculation, this part is gonna be 0 and you are gonna have only 1 of them. So now let's do it. So now I just put them in a group of 4 and now I'm having 3 group of 4 and I'm having this table in front of me. I go find the equivalent for each of these groups. and I put it underneath, and that's how I convert binary to hexadecimal. Let's do it together. First one is 0101. I look at here and see which one is 0101. This one. If I want it in decimal, and if I want it in hex, both of them, for these numbers, both of them are equal. But anything after 9, decimal and hex are not equal. We use some alphabets for the hex equivalent after 9. So 0101 is equal to 5. 1111, I'm looking for hex. The equivalent in hex is F. 1001, what's the 1001? 9. Then what would be, so this number is base 2. What would be the result in base? What is the hex base? 16. Therefore, it should be 9, F5. I missed the F. 9, F5 in base 16. Makes sense, kids? Which is hex, right? Everyone got the point? It becomes a little bit more tricky when you have been asked to convert otherwise. If you are planning to convert hex to binary, this is again binary, and that's hex. If you have been asked to convert hex to binary, it's a little more challenging because you cannot directly convert hex to binary. First, you have to convert it to decimal, and then you have to convert it to binary. Make sense? So let's do that now. Now I'm having another number. Let's say I'm having 29B. 29B is base 16, means it's hex. I'm going to convert it to binary. What do? I look at my table. What is 2? 2 is 0, 0, 1, 0. Right? What is 9? 9 is this one. 1, 0, 0, 1. How about B? 1, 0, 1, 1. And this is going to be base 2. Still with me? Everyone got the point? Yeah? Okay. Now, let's convert another number. I'm having 45. Remember I said if I'm having decimal to hex, it might be a bit challenging. I'm having 45 base 10. And I know base 10 means decimal. And I'm asked to convert it to hex. What I'm going to do in here? Any idea? Any idea? Who can convert this one? 10 to 16. How do I convert? There are 2 methods to convert. One method is, which is the easiest method, if I have like 45 to be converted, one method is dividing it by 16. Very similar to the way that we are converting 10 to 2. Remember, I was dividing it by 2 until I have all the remaining to be 0 and 1. So one method is doing the same, dividing 45 by 16. What would be the number? And then next time, I have 2, right? Then dividing 2 by 16. Then it becomes 0, right? So then I have 2. And anytime I have 0, which is less than 16, I have to add, right? Because this is going to be most significant digit. This is the most significant bit. And this guy in here, this one, 45 divided by 16. This one remainder is going to be 13 in here. This one remainder in here is going to be 2. If remainder is 13, 13 is equal to what? I'll go back to the table. 13 is equal to D, right? So I'll take it from the table. 13 is equal to D. So this is going to be my least significant bit or digit. Either is correct. Then what would be the conversion result? So I have 2 as most. Always I start with most and then I'll take the least. So yeah, if I have it like that, result is going to be 2D. And what's the base? Base is 16, again, which is hex. So conversion of decimal to hex. Everyone got the point? Yes? Next, let's do another example to make sure everyone is comfortable in here. Next example, I'm going to convert maybe a combination of letters and number to make it a bit more complex. So I'm going to convert 6B2. And this one is again hex, base 16. I'm going to convert it this time to binary and then binary to decimal. So first binary, then binary to decimal. That's the second method. Remember I said either if it is only number, I can start with dividing it by 16. But if it is a combination of number and letter, I have to convert to binary and then binary to decimal. A bit challenging, but doable and easy to understand. So what's the equivalent in binary? What is 6? I'll go back to here. 6 in binary is 0, 1, 1, 0. I take it, I put it down. In binary, 6 in binary is then. How about B? What's B in binary? B in binary, 1, 0, 1, 1. How about 2? 2 in binary, 0, 0, 1, 0. So I'm gonna 0, 0, 1, 0. I'm gonna remove this. So this is the binary. Now I have to convert binary to decimal. To convert binary to decimal, I have to go through that process of, these are base 2, right? I have to go through that process to convert binary to decimal. That's one way. Or if I want to convert it again using the same method of dividing by 16, I can do that one. That one is a good one to learn. I can do also that one. So this one, now you know how to convert because we already did it. Let me do the other method. So I'm gonna, again, convert it by base 16. If I want it to be by base 16, first I know B is equal to 11, right? So if B is equal to 11, then I have to, in order to calculate the sum, I have to say 6, I have 6 in here, times, I'm gonna use it like this, 16 to the power of 2. Why I say 2? Remember I say, if I have 3 numbers, I have to start from 0 and stop at 2. That's why I say 16 to the power of 2. What's next? Next, I'm gonna say B. But I cannot say B times 16 to the power of the 1. How do I say it? I already said B is equal to 11. So I say 11 times 16 to the power of 1. Make sense so far? Now, the very last one is again 2. 2 times 16 to the power of 0. Then use your calculator. It's going to be 17 14 base 10. That's how we convert. So one method is direct conversion, which I just did it right in here. This is the direct conversion. Direct conversion means calculated based on base 16. And non-direct conversion means first convert it to binary and then binary to decimal. Because binary to decimal, like in here, binary to decimal. I did it right in here. This is binary to decimal. So we have 2 methods. But during the exam, yes.
We have access to that.
Yes. Yeah. During the exam, you will be clearly asked, do it direct conversion or binary to decimal? Most of the time, I'm asking you to do it binary to decimal, not direct. Because I want you to show your skill converting first binary to decimal, then decimal to hex. So still, I remind you when we are there, but have it in mind for exam, always do non-direct, means first binary, then binary to decimal. Again, binary to decimal means calculated based on, for example, here we have 0 to 2. You have to start just all of this 0 times something, so on. Make sense? So, now a little bit more advanced. How do we add up to maybe binary numbers together or 2 hex numbers together? Let's do that quickly. Suppose I'm having 1101. This is one of my numbers, and then I have 1001. I'm gonna add them up. How do I do that? So this is a general rule in order to calculate. So anytime I have 2 zeros to be added to each other, carry is 0, sum is 0, right? So in here, I have 1 and 1. 1 and 1 is 0 and I carry 1. Means I put 0 in here, I carry 1 to the next. Then I have 0, 0. I said 0, 0 is just 0. Carry and sum both are 0. But since I have a carry from the previous step, it becomes 1. How about 1 and 0? 1 and 0, carry is 0, sum is 1. Therefore, 1 and 0 is 1. 1 and 1, I already said. 1 and 1, I have a carry and I have sum. Make sense? You got it? That's how we add up 2 binary numbers. Those who are sitting in the back of the class, are you still with me? Can you see everything? Any question? Feel free to ask, kids. I'm okay if you ask. I don't judge you. I never judge anyone. Now, I'm having binary to decimal. This is one method. Either I can first add up this whole thing and then directly convert this one to decimal, or I can do it individually. For example, the decimal equivalent, I'll go back to the table. Decimal equivalent, keep it in mind. 1101 will go to the table. I can even bring the table here to not to have constant trips here and there. So then I'm going to look at here, 1101. 1101 is what? The decimal equivalent is 13, so I put it down. Then I have 1001. 1001. What's the decimal equivalent? It's this one, 9. I put it down. And this becomes 22. So either I first find the equivalent in decimal for each of them individually, then I do the summation, or I finish the summation in binary and then I convert it to 22. Either will work. Make sense? Next. This one was just two binary number, easy to understand. Now let's do two hex number. How do I add two hex number? Let's practice this one together. In order to add up to hex number, suppose I'm having 23D9 and I'm having 94BE. Again, either I have the option to individually figure out what the decimal equivalent is for each of these two numbers, or I can add them up and then convert them. So now I'm gonna do it like this. First is 2. 9 plus E. 9 plus E means what? And I want you for the exam one more time, always include all the steps. Do not leave the step in your maybe note. It has to be inside the exam sheet. So 9 plus E means what, kids? E is what? E is 14 from here. This is E is 14, right? So it's 23. What is the rule? The rule is anytime I have the summation to be greater than 16, I have to subtract 16 from that number. In here, I have it 23, so I have to subtract, like in here. I have to say 23 minus 16 and find 7 with a carry. So then I put down in here, this is 7. 9 and E becomes 7 with a carry. Next, a carry means I have 1 in here now. So next, I'm gonna do next step, which is, I have a carry, which is 1. Then I have plus D. Then I have plus B. Figure out what is D. D is gonna be 13. B is gonna be 11. I add them up, it becomes 25. Again, 25 is greater than 16. What do I do? Somebody say it. Subtract 16. 25 minus 16 becomes 9. Again, I'm having a carry. Anytime I subtract 16, I'm having a carry. Means now I have a carry in here. So I put 9 in here with carry 1. How about next step? Let's do next step. Now I have 1, 3. This is easy. Then I just add 1, 3, 4. 4. It becomes 8. I don't have carry for this because it is less than 16. So I can simply just put the same number 8 in here with no carry. And last step is going to be 2 and 9. 2 plus 9. 2 plus 9 is B. I don't need to convert it. I just keep it as B, right? So this one is going to be my next one, which is B. Remember, I always start from most significant bits, which is this one, MSB, to least significant bits. Right? That's why I have this one. So you have to just travel from here. Make sense? You got it? Still with me, kids? You got it? How I did it? Okay. Let me practice another one and gradually wrap up. Another one is going to be 2, maybe another number. Let me use 5, 9, because that was summation. Let's do subtraction. 5, 9F minus 2B8. How do I do this? This time, instead of subtracting 16, anytime that the second digit is greater than the first digit, I have to borrow 16. I don't subtract 16 for subtraction. I borrow 16. Like what? So suppose I'm gonna start from here again. So I have to say, and everything in here is going to be my least significant bit. I'm gonna say 8. So F, one more time, kids. I'm gonna put the table in here to be close to you. One more time. What is F? F is 15. So I'm gonna say 15, which is F, minus 8. This is easy. This is 7. So I can use the same number right in here. Next is this one. This one is, I'm going to say 9 minus B, right? 9 minus B, B I know is greater than that. B is 11. So if I say 9 minus 11, that's greater, right? So I cannot do it that way. Therefore, I have to, remember, I have to borrow 16. So I have to say 9 plus 16 minus 11. That's the rule. Anytime that the first number is smaller than the second one, then I have to borrow 16. Then I have to say minus 11. It becomes 14. What is the equivalent for 14? This is 14. Equivalent is E. So I can just have it as E. And I put it down in here as E. Make sense? Next one. Next one is the last one. Therefore, this is going to be my most significant bit. I'm going to have 5 minus 2. But remember, because I already borrowed 16 in here, therefore this 5 is already 4. It's not 5 anymore because I borrowed. Therefore, this is acting as 5 minus 1, which I'm gonna replace it with 4 because I already borrowed. Make sense? Then this is going to be 2. And I substituted it right in here. Now, the result is going to be this one. Make sense? Everyone got the point? So, I leave this few questions in here for you because this is going to be a summary of answer to this question, a summary of what I already explained to you. This is a self-assessed question for you. Go through them yourself. How do you convert this stuff? And then I'm going to look at some binary logic. In addition to whatever about the numbers that I explained them to you, there are some logics that you need to understand in order to be able to communicate with the computer. So let's start with AND gate. Each of this logic, they do have their own symbol, right? So let me expand this. Symbol for AND gate. And again, these are going to be binary, kids. We call them binary. Look at here, binary logic. Binary logic means logics that are based on 0 and 1. For example, if X is 0, Y is 0, and this is and means summation, what will happen? So if both of them are 0, then I'm gonna have 0. 0 and 1, 0. 1 and 0, 0, and so on. I'm not going to read them for you. So you may want to just look at them. In here, I'm having OR. This is AND. Look at the symbol. They have a different symbol. Still, it's important what I am sending to each of these variables, 0 or 1, on or off. Suppose I'm sending 1 and 0. If it is 1 and 0 as my variable, and my gate is an OR gate, 1 or 0, 1 or 0 is 1, and so on. Now I'm having a NOT gate. Anytime you do have this empty circle, tip of each of these things, because all of those could be converted to NOT. If I'm going to convert them to NOT, I add just an empty circle right in here. If I do so, then instead of or, it becomes not or. Instead of and, it becomes NAND. Now this one is not only, not. Not if it is 0, not, then it is 1. And otherwise, 1, not, if it is not 1, it's 0. Makes sense, right? And so on. So anytime we have it open, is it 0 or 1? If we have it closed like this, is it 0 or 1? 1. That's why we need to understand what will happen. Suppose this is a switch. If switch 1 is open and switch B is open, then I'm not having an output because 0, 0 is 0. For example, I'm not going to have any voltage. Both of the switches are open, the circuit is open. If this one is closed, this one is open, it depends what other components I have. But generally, still means circuit is open in here. It's 1 and 0. 1 and 0 means again, I have nothing. Circuit is open. And so on. Make sense, kids? I already said I have these two, NOR and NAND, in the previous slide. If I add this one, the same symbols for and or, they are gonna become reverse. Anything I had in here for and or, when I add this, guys, it becomes opposite. So for example, now if I have 0 and 0 and 0 and 0 is 0, but 0 NAND 0 is 1. It's opposite. Make sense? And so on. XOR. XOR 0, 0 means 0 XOR 0 is 0. 0 XOR 1 is 1. And so on. We can do some logic gates summation. We can add them together. We can add, like, for example, not to and so on to create summation. Something like that. If I have something like this is, we already know this is XOR, right? I just learned it in here. So I know this is XOR. If I have an XOR in here, and then if I have an AND in here, and I'm having the same input for both of them, so it's gonna be called a half adder. It's a half adder because I have a sum in here and I have a carry in here. So this becomes a half adder. This is another half adder, but I'm having like not being added to and. This is and, this is not. And then another not in here, another and in here. And then I'm getting one output, let's say O1, and then I'm getting the second output to become the input of this. What is this? OR. So output of this and output of the other and are going to become input for the OR. And then I calculate the sum. Like for example, 0 in here. 0 and then 0. If I go through the process, if both of them are 0 in both systems, then I'm going to have 0 as a sum. And so on. So this is a half adder using XOR and. This is a half adder using and or not or invert. Not or invert is the same thing. We can call it even invert. This is the same as not. Make sense? I'm gonna just close up the session with few multiple choices question. This is your time to answer my question, and then we are gonna wrap up. So based on whatever we've discussed from the beginning of the session, answer my questions, please. The logic operation, then I'm having blank, gives a 1 output when all inputs are 1. Which one is correct? And, not, X or NAND? And, 100% correct. Next, the logical operation gives a 1 output when one or more of its input is 1. Which one is correct? 100% correct. Next, the CPU has address bus of 16 bits. It could provide which kind of memory? 64K. That's correct. And the very last question, state which of the following is bidirectional. Data bus, address bus. I explained this during the lab. Data bus. Any question for me? That's it for today. How was it? You like it? Everybody learned the lesson?